Hi guys, so in this video I am going to be going over what factors and prime factorization looks like. I am using the 6th grade textbook. The setup should be familiar to you. You will have some practice to do outside of this video, so please make sure in your math checklist you are looking for that link. So here is the lesson. Please come back to this video as much as you need to in order for you to fully understand it and successfully get the lesson done. If you have any further questions, you may comment on the video. If you think everyone will have this question on our Google Classroom checklist, or privately message me. So let's get going. So we are first going to talk about finding factors. So right here it says whole numbers that are multiplied to find a product or an answer are called factors. A number is divisible by its factors. So for example, for the product of 6, 2 and 3 are factors because when you multiply 2 times 3, you get the product of 6. And then over here, it shows you how 6 is divisible by 3. 6 divided by 3 is 2. And 6 divided by 2 is equal to 3. So you can kind of see the example of how the factors find the product, but the product is also divisible by the factor. So you can kind of see that connection there. Down here, you're going to see 2 examples about finding factors and listing them. So you can list factors in pairs. So if your product or if your number is 18, you can list the factors in pairs. So 18 equals 1 times 18. 2 times 9 also equals 18. 3 times 6 also equals 18. You can kind of see it right down here as well, this little chart, 1 times 18, and this has the numbers in chronological order, 2 times 9, and 3 times 6. And then you actually list all of the factors in numerical order. So they are 1, 2, 3, 6, 9, and 18. Don't forget about the number 1 and the product itself. For numbers such as 13, 13 only has 2 factors, which is 1 and itself. You will come across numbers that are like this. It says right over here that begin listing factors in pairs. 13 is not divisible by any other whole numbers. Okay, so for that example, it is just 1 and itself. I will do an example over this in just a second, but before we get to that, I want to talk about prime factorization as well, so I can do the examples together. So the prime factorization of a number is the number written as the product of its prime factors. Okay, so for example, let's go to the next page. This is probably the most common one that you may have seen already. Sorry. The first method is creating a factor tree. So you choose any 2 factors of 36. So for example, they chose 3 and 12. Keep finding factors until each branch ends at a prime factor. So a prime factor is no other numbers can go into it besides 1 and itself. So they went ahead and circled 3 because only the numbers 1 and 3 can go into 3. So you cannot break that down any farther. So it is prime. They also did 3 times 12. 12 can continue to be broken down. They chose to break it down into 4 times 3. Again, we have the number 3, and so they went ahead and circled it because it is prime. And then they continued to break down the factor 4, and it broke down into 2. 2 is a prime factor as well. And so the prime factorization for this one would look like 3 times 2 times 2 times 3. These little tiny dots mean that it is multiplication. You could also write it as 2 to the power of 2 times 3 to the power of 2. So you can write it as if they are exponents because there are 2 of them. If you were to actually multiply 2 times 2, like this is telling you here, it would get 4. That is the same thing as 2 times 2 right here. Over here, they broke it down a little bit differently, which is okay, but you will still end up with the same prime factorization. Your factor tree will just look a little bit different. So they chose to do 2 times 18. 2 is prime, so they circled it. 18 can be broken down into 9 times 2. 2 is prime, so they circled it. 9 can be broken down into 3 times 3. Both of those 3's are prime, and if you see right here, they get the exact same prime factorization of 2 times 2 times 3 times 3. The second method you can use is a ladder diagram. So it says choose a prime factor of 54 to begin. Keep dividing by prime factors until the quotient is 1. So the number is 54, they divided by 2, that gets you 27. 27 divided by 3 gets you 9. 9 can be divided by 3, which gets you 3. 3 can be divided by 3, which gets you 1. So these numbers in red would be your prime factorization, as you see below. 2 times 3 times 3 times 3. And then over here, you can take a little bit of a longer look at it, but it kind of just shows you the exact same problem, but dividing a little bit differently. So I am okay if you use the factor tree or the ladder diagram. That is completely up to you. So I am going to give 2 examples real quick of one where we are just listing the factors, and then one I am going to do the prime factorization of it. So let's go ahead and look at the number 12. We are going to list the factors of 12. I am going to list them in pairs first because that makes sense in my brain, and then I'm going to rewrite them in numerical order. So the numbers that go into 12 are 1 and itself. I know that 2 goes into 12, and 2 times 6 is 12. I know that 3 can go into 12, which is 4 times. And then I can kind of just keep going in numerical order to see if there are any other factors, just to be sure. So I know 5 can't go in. I know 4 already goes in. I know 6 already goes in. 7, 8, 9, 10, and 11. I know those don't go in. So these are my factors. So I am going to list them in numerical order below. So I have 1, 2, 3, 4, 6, and 12. I'm going to give you guys just kind of a whole picture so that you can see it. Sorry, I'm using my phone camera and it's not the best, as you guys know from class. So you can see right there, I listed them in their factor pairs, and then I listed them in numerical order below, which would be my final answer. So I'm going to come over here. I'm going to come over here, and I am going to do the prime factorization for the number 48. Okay, so I'm going to do the factor tree. So now I need to think of, okay, what times what gets me 48? Well, I know 12 times 4 gets me 48. Neither of these are prime because they can be broken down. So I know that 2 times 2 is 4. I also know that 1 and itself only goes into the number 2. So both of these are prime, and I'm going to circle it. So that means I am done on this side. Let's see what 2 numbers gets us 12. Well, I know that there's 3, and I know that there is 4. Okay, I know only 1 in itself can go into 3, so it's prime. So I'm going to circle it. And I know that 4 can be broken down into 2 times 2. Because I've done that over here already, I know that 2 is prime. So I'm going to go ahead and circle those as well. Now I am finished because I have nowhere else to continue. At all of my ends, I have prime factors. So now I need to list the prime factorization of it. Typically this you would do in numerical order too, so I'm going to start with 2. So you can see that I have 1, 2, 3, 4 2's circled. So I have 2 times 2 times 2 times 2. And then you can see I have just 1 3 circled. So I'm going to add times 3. I am going to make this look just a little bit easier on the eyes, and I'm going to write 2 to the power of 1, 2, 3, 4. Because I have 2 listed 4 times, and I have 3 listed once, so I have 2 to the power of 4 times 3. And that is my prime factorization.